Sathyabama Institute of Science and Technology.
A warm welcome to all. This is Dr. D. Kanchana, Assistant Professor, Department of ECE from Sathyabama Institute of Science and Technology, deemed to be University, Chennai. Today we are going to discuss on the topic of derivation of S parameters of magic tea or hybrid tea and its applications. So before going to the topic, let me introduce what is S parameters first, why we are going for the S parameters. So S parameters is nothing but your scattering matrix that is used for the high frequency response. So some of the low frequency parameters are we used like Z, Y and H we can use. So why we are going for the high frequency parameters means here we can use it for the reflections coefficients and transmission coefficient parameters we can find out by using the Z matrix. So next thing is for S matrix we have multi-port networks we'll use. So in the case that if you see here we have shown in the figure 1. So we have the outputs has been mentioned as B matrix and the input that is nothing but your S matrix and then your A matrices. So we are going to find out our reflection coefficients and transmissions coefficients. So the reflections coefficients are, so what are the reflections coefficients we are going to find out means, so the S11 and S22 are your reflections coefficients. The second thing is transmissions coefficients. We are going to transmit two things. So from forward transmissions coefficients and reverse transmissions coefficients. So forward transmissions coefficients is nothing but from first port to second port we are going to discuss. So the reverse transmissions is nothing but from second port to first port. That is what we have mentioned. S21 is a forward and S12 is a reverse transmissions. So the next thing is, before going to the derivations, we have to know about the properties, because these properties are the things we are going to add in the derivations. If you see here, the first property is square matrix. The square matrix is nothing but n cross n matrix. In the sense we have to use a 2 cross 2 or 3 cross 3, like that we have to use. So that's why it is a square matrix. So the second property is nothing but it is a symmetric matrix. That is nothing but in case we are using S12 means the same thing will happen in the S21. That is what we have mentioned. Sij equal to Sj1. So I is not equal to the j, means S12 equals to S21 we can write it. That is called as your symmetric matrix. The third matrix is nothing but is a unitary matrix. So we all know about the unitary matrix. The S matrix and complex conjugate of S matrix is the unitary matrix they have mentioned. The fourth one is nothing but it is a zero diagonal. In the sense, if the ports are perfectly meshed, that is called as your zero diagonal matrices. So Sij equals to 0. So like example, S11, S22, S33 and S44 are 0. If it is perfectly meshed, we can add it as a zero diagonals over there. The fifth one is nothing but the sum of the products of each terms, like rows and columns we have to find out. The terms of that complex conjugate we can write it as a equals to 0. That is what written in the equation. Summations I equals to j of n, Sik is complex conjugate of Sik we can written it. So now move on to the topics, the magic tea. So what is magic tea? What are things we have needed? Magic tea is a 4-port networks, we know that. So we have to use the S parameters as 4 cross 4. This is a square matrix. The second thing is, if you are giving the input in the signals input means, so it is divided. For example, I will tell you. So we have 2 collinear arms, 1 and 2 is there. The next thing is the third port we have taken as the H-plane. So this is your H-plane and the upper port is a E-arm. They have mentioned as E-arm, that is your fourth port. If you are giving the input at the third port means it will split it out to the first port and second port. That is nothing but your collinear arm. That port they will send. So the above port, the E port will be isolated or terminated. So same like that, it is vice versa for the E port. So if you are giving signals at the E arm means the H port will be terminated and isolated. So it will move on to the port 1 and port 2. That is nothing but your collinear arm. So next is, it is a combinations of both E-plane and H-plane. So generally we studied about the E-plane and H-plane. So E-plane means nothing but it is a out of phase, same amplitude and out of phase. H-plane is nothing but same amplitude or equal amplitude and same phase. So next we move on to the operations of magic disc. So we have 4 cases in that. So the first case is when 2 signals of the equal amplitude of feed from port 1 to port 2 will give port 4 as 0. Nothing but your E plane will be 0, only H plane will go on. So the next thing is when a signal is fed through port 3, it is divided equally between the port 1 and port 2 and the outputs are in same phase. Same phase means nothing but your H-plane. So we are giving on the input at the H-plane, it is split it out. So it is same phases. The third one is nothing but, so we are going to give the signals at the port 4. So if you are giving there means it will move on to the port 1 and port 2, the collinear arms, and we will get that negative signs because it is out of phase. 180-degree phase shift has been done. So the fourth point is nothing but if a signal is fit at a or one of the collinear arms, either first port or second port we are giving means there is no outputs in the first port or second port, okay. So that has been mentioned as 0. So that is what they have given here in the fourth cases. The next thing is, so we said it is a 4 cross 4 matrix. So we have to write S matrix in the 4 cross 4. From S11 to S44 we have to written that. The next one is, we have mentioned the H-plane is the third port network, right? So the third port network means that will split it to the port 1 and port 2. So that's why we have returned as S23 equal to S13. Because of the symmetric port property, we have returned like this. The next one is E-plane. So as we mentioned before, E-plane is nothing but you are out of phase. So if it is out of phase means we have to mention that opposite sign, minus sign. So we have written S24 equals to minus S14. So this is how we have taken. The next thing is, if you are giving the input at the port 4 means we will not receive outputs, any outputs at the port 3. So that is nothing but, so your S34. So same like that, if you are giving at the port 3 means there is no output at the port 4. So S34 and S43 are 0 here. So as per the properties, we have the symmetric properties. We know that Sij equal to Sj1. So we have to write as such, like S12 equal to S21, S13 equal to S4. So same like we have to write, but at the case of S24 equals to S42 equals to minus S14 we have written, because we have applied the E-plane conditions, right? S24 equals to minus S14. So we have to write it like that. S24 equals to S42 equals to minus S14 we have to return. The next thing is zero diagonal we discussed in the properties. That zero diagonal is nothing but you are perfectly matched. So we are taking for the port 3 and port 4, right? So we have mentioned S33 equals to S44 equals to 0. You can write it as S11, S22, S33, S44 all equals to 0 because everything is perfectly matched here. So next thing is, we have to write that S parameters. So we already know that we have substituted some equations. We have to arrange like that. So if you see here, the port 3 and port 4 will not give the input as well as the output. So we have mentioned as S34 equals to S43 equals to 0. Then the perfectly matched is nothing but S33 and S44 we have mentioned 0. So that particular part has been written as 0, 0, 0, right? The next thing is, you know that unitary properties. So S and S conjugate equals to I. So we have to write it like this. We know that S matrix and the complex conjugate of that, and then the corresponding unitary matrix has been written over here. So next what we need to do now? So we have to calculate the row 1 and column 1 values. So how have been written means S11, S11 star. So we can written as S11 whole square, right? The modulus of S11 whole square, S12 whole square, S31. Like that we have to written row column 1 and row and column of 2, row and column of 3 and row and column of 4. That is what I have mentioned as R1, C1, R2, C2, R3, C3, R4, C4 we have written. So next thing what we need to do now, we have to find out the values. So I have taken the equations number 10 over here. If you see here, S13 the whole square plus S13 the whole square equals to 1, we have know that. So we can write it as 2 S13 the whole square equals to 1. In terms of S13 now, we can write it as 1 by root square, right? So we have written like this. So the next thing, we have to take the 11th equations. For 11th equations, how does it will come now? S14 equals to 1 by root 2 will come. You see here, S14 equals to 1 by root 2 we got it. So the next thing is, we have to compare the 8th and 9th equations. So if you are comparing means, so the minus value will come. So we have to compare these two equations. This is nothing but your R1C1 and R2C2 we have to compare. So comparing these two equations means that values, what are the values will go off? So S12 will go off, next S13 will go off, S14 will go off. The remaining will be a S11 and S22 will be there. So if you see here, S11 and S22 is there. So the next thing is, we have to compare 12th and 13th equations. So we have to substitute that. What are the findings we have find out? S13, S14, S11 and S22 we have find out, right? So we have returned in the equation set. So S11, S12. So the N3 the whole square is nothing but 1 by 2 we can write as. Same like S14 we can write as 1 by 2 equals to 1. So the remaining will be S11 plus S12 equals to 0. So we can write as S11 and S12 equals to 0 over here, right? So the next thing is we have to know that. So substituting the equations. So as we discussed earlier, if it is perfectly matched, we can write it as S11, S22, S33, S44 equals to 0 because of the zero diagonal matrix. So we have find it out. So next what we need to do now, we have to substitute all the equations in the S parameters. So we have that S matrix, right? We have to substitute that. So after substituting, we have got this results 0, 0, 0, 0. So this is nothing but if one of the port have values means the other ports we will get the values. So that is what they have returned. So we have returned as what? B equals to S into A we have returned. So the next thing we have to write as for 4 matrix. So B is nothing but B1, B2, B3, B4 are the outputs. So we find out the S matrix into the A. So we have to find out B1 equals to what the values will come for this. So B1 means this 2 will be 0 1. So 1 by root 2 A3 plus 1 by root 2 A. We can write it like this, right? The next one is B2. So the B2 is nothing but 1 by root 2 A3 minus of 1 by root 2 will come. Next is B3 is nothing but 1 by root 2 A1 plus 1 by root 2 A2. So B4 is nothing but 1 by root 2 A1 minus 1 by root 2 A2 will come. So this is how they have written the equation number 18. The next thing, some of the findings from the magic teas are, the first case we are going to take it as A3. Already we have discussed A3 is nothing but your H-plane. So we are going to give the inputs at there. So that is what they have mentioned. A3 is not equals to 0 because we are going to give the signals, input signals over there. Next A1, A2, A4 are 0. If you are keeping like that, so we know that H-plane means we have to get that positives, means in the sense of equal amplitude and same phases. So if it is equal amplitude and same phases means what will happen? So it is nothing but we have to get the positive signs. So if you see here B1 equals to 1 by root 2 A3 plus A4. So we can write as B1 equals to A3 by root 2 and B2 equals to A3 by root 2. So other things are B3 and B4 are 0 over here. So this is nothing but your H-plane. The next thing is we are going to find out for the E-plane. So we have kept as the E-plane as the fourth port. So I have mentioned A4 is not equals to 0. So the remaining things A1, A2, A3 are 0. So we know that E-plane means what we need to do. So if it is E-plane, we have to make it as minus values because they have the opposite phases, equal amplitude and opposite phases. So we have minus value. So substituting this equations means B1 equals to A4 by root 2, B2 equals to minus A4 by root 2. So it is nothing but your E-plane team. So next what we need to do now, we are going to make it as A1 is not equals to 0, A2, A3, A4 equals to 0. So we already discussed if any one of the ports are like port 1 and port 2 we are giving now, there is no output at the port 2, right? This is port 2 or port 1. This is what we discussed. The same thing when power is fed into the port 1, nothing comes out of the port 2, right? So even though they are collinear ports. The second point is in port 1 and port 2 are called as isolated ports. So they will not come. So no output at the collinear ports, hence it is a magic. So this is what we have found out. B1 equals to 0, B2 equals to 0, B3 equals to A1 by root 2, B4 equals to A1 by root 2 we got it. So some of the applications of magic teas are nothing but measurements of impedance. The second thing is magic tea as a duplexer, third is mixer and fourth one is isolator and power combiner. For that purpose we can use the magic tea. Hope you understand this magic tea applications. Thank you so much.